everyone, welcome to my channel and welcome to this video, which is going to be about the Pythagorean Theorem, which deals with side lengths of right triangles. I hope that if you haven't been here before that you will stay and that you will enjoy what you're learning. So please click subscribe, and a like would be amazing. Those are free ways that you can help me out, and I hope that you'll enjoy what we learned today. So without further ado, let's get right into it. As I said, the Pythagorean theorem is only applicable on right triangles, and those are triangles that have a right angle, meaning 90 degrees. So it's important that you understand what the sides of a right triangle are called. So this side right here, the one that's diagonal, the one that's opposite of the right angle, that one is called the hypotenuse, and it is always, without exception, always the longest of the three sides. Now, as far as these two, you can call them whatever you want. I mean, they are sides. You can call them the legs of the triangle, base and height, length and width. It matters not what you call them. Just know that they are the two sides that create the right angle. So let's talk about what the actual Pythagorean theorem is, and then I'll talk to you about some really important points. So let's do that. All right, I put what I was saying onto the board here. So the actual formula is a squared plus b squared equals c squared. It's very common in math. You'll use it a lot in a lot of different situations, and so really good to make sure that you understand it. Now, it's very common that the sides are labeled as a and b. They can be any variable, and it's common that the hypotenuse is labeled as c. Again, it can be anything. Don't get too locked into those letters, or if it gets changed, you might get thrown off. So remember, the hypotenuse is always the longest side out of the three, and the Pythagorean theorem just says square and add the sides, and that always equals the hypotenuse squared. So a and b are just the sides that make the right angle. They can be switched. You can put a here, b here. Like I said, you can call them anything. Base, height, Fred and Steve, I don't know, whatever you want. But it's just important that you understand when to use the formula and how to use it. Now, something that you won't generally see with the Pythagorean theorem, but you really should make note of, is if a and b and c, or any of them, are negative, or if they are more than one number, for example, 2 root 3, you really want to put parentheses around them when you plug them in. So let's do a bunch of examples and you'll see what I'm talking about. You can use the Pythagorean theorem when you know 2 out of 3 sides of a right triangle. It doesn't matter which one you don't know, it just matters that you know 2 of them. So what you want to determine is which are the sides, so which are your a and b, in this case the x and the 12 because they make our right angle, and our hypotenuse is 13. So we're going to set up the Pythagorean theorem like this. Pretty easy to set up, it's really not too bad. So now all you have to do is just do the math. I know, who'd have thought? So now you're going to square the 12, square the 13. So we're going to have that equation right there. So now remember that we're trying to get x alone. We want to know what it's equal to. So we're going to want to subtract 1 and 4. So we're going to want to subtract 144 from both sides to get the x squared alone, and then we'll deal with the squared after that. So let's subtract 144. So I'll have x squared is equal to 25. Now, do you know what cancels off a squared power? So for example, adding and subtracting, they're opposites and they cancel. Multiply and divide are opposites and they cancel. But when you have a square root would be the opposite. So we're going to square root both sides. I like to draw it like this. And then I like to cancel off the squared and the root to remind myself, hey, those are opposites, so they're going to cancel each other out, leaving us with x alone. Now, the square root of 25 is just 5. So what that means is, when you have one side length of 12 and a hypotenuse of 13, the other side will always be 5. Obviously, this isn't drawn to scale because it looks like it's longer, but actually that's a good lesson in math overall. Don't rely on the pictures. They're usually not drawn to scale. They might try to trick you, but don't fall for it. In fact, your right triangle should have a little corner like that in the corner to symbolize that it's a right angle. So let's do some more without such perfect whole numbers. Notice I've turned the triangle. It's not always going to be handed to you on a silver platter like, hey, here's this perfect triangle oriented exactly this way. You have to keep in mind that it can be turned or oriented however. So that means that we need to be able to identify the hypotenuse, which is x, because the one that's opposite of your 90-degree angle is your hypotenuse. These are your sides. Again, it doesn't matter if it's a and b, a and b, a and b, whatever. All you want to know is that we're going to take 7 squared plus root 26 squared equals x squared. So let me set that up real quick and then we'll solve it together. Notice I've put parentheses around the square root 26. You don't have to, but when in doubt, use more parentheses than you think you need. So anytime you're putting it around a root, a negative number, like I said, if there's more than one number, which we'll see on the next problem, then use parentheses to your advantage. In fact, in the past, I have taught this formula where you have to put parentheses around a, b, and c on every problem, because what I see a lot is that if you're not used to putting parentheses every time, then when you absolutely need them and it's crucial, you forget. And by you, I mean the world. So let's make sure that we use parentheses to our advantage. So let's solve this out. Notice the x squared is already on the side by itself, so let's work on simplifying this side first. So 7 squared is 49. Now remember that on the last problem when I had x squared and then I rooted it, those cancel. Well, guess what? We have a squared and a root right here, so those are going to cancel as well. So this is what it's going to look like. Well, that's nice because now we don't have a root anymore at all. We just have whole numbers. So let's add those together and see where it heads from there. So 49 plus 26 is going to be 75 equals x squared. So now we're going to do what we did on the last one and square root both sides. So this is what we have right now. Now I kind of left this blank because we need to know how to simplify root 75. Now if you're not sure how to simplify square roots, I've got a video for that. Check it out. It's up here and I'll try to remember to link it in the comments below as well. Now, you could just throw it in your calculator. Square root of 75, you'll get some awful decimal. But oftentimes, in fact, more often than not, you actually want to leave it in root form, so you just want to simplify it. So we're going to break the root down and look for pairs of numbers. So this can be 3 and 25, 5 and 5. Can we erase this? Move it down. All right, so pairs of numbers get to leave the root together. Anyone who doesn't pair up doesn't leave. So what this means is we're going to have 5 root 3 is equal to our x value. So that is our solution. So I hope that makes sense. Let's do some more with roots to get even more practice. Remember what I said a minute ago about not being drawn to scale? Case in point, that's supposed to be a right angle. Use your imagination. So remember that since the right angle is here, that the x and the root 13 are going to be your a and b because they're the sides that make your right angle. The 2 root 5 is your hypotenuse. So this is how it should be set up. Now again, I have a 2 root 5, so you especially need to use parentheses around that guy. So let's, and by let's I mean, I'll set this up and you can watch me. Now notice I put parentheses around both of the root portions so that I'm being more thorough. So let's simplify what we can. Now notice that the square root and the squared are both over the 13 here, so they will be able to cancel. We'll have to do something a little special here, so let's do that in just a second. So we're going to have x squared plus 13 equals. Now, in this case, you can't just cancel the root and the squared because this whole thing is being squared, including the 2. So one way that you can do this is to write them separately with the squared on each one. Like this, you'll see. So you can see each one is being squared. So that means 2 squared is going to be 4, and root 5 squared, that's where your root and your squared will cancel. So let me simplify this and you'll see where I'm headed. Notice that I put a multiplication sign in between, but that's because it's 2 times root 5, so 2 squared times root 5 squared, therefore 4 times 5. So now we'll just multiply the 4 and the 5 and continue on. So we have x squared plus 13 equals 20. We're going to subtract 13 from both sides. So just like the regular equations from earlier, and then square root both sides. Now with the square root of 7, 7 is prime. It doesn't break down. So if your number can't break down, or when you do break it down, if it doesn't have any pairs, then that's just your answer. You can't go any further, so the answer would be root 7. It's very, very common when you're dealing with the Pythagorean theorem to have a lot of roots involved, whether they're in your answer or your originals, or both of those things. You're going to see them a lot, so it's important that you understand how to simplify roots. So again, check out my video on doing that. So let's do some more. Another one with roots here because I think it's really important to understand how to do them. So let's set this up by realizing that the 3 root 2, that's your hypotenuse. It's almost like this right angle little pointer thing is pointing straight towards the hypotenuse. Wow, math, not English, let's just go with that. So let's set it up with a plethora of parentheses equals 3 root 2 squared. And let's solve it just like the last one. So since the squared and the root are both over the 6 here, those will cancel. But on this one, we need to square each piece. So let me write this out and then we'll go over it. I squared each piece like I did on the previous one, so that gives me just 18. So I went all the way to x squared plus 6 equals 18. Now, since we're trying to solve for x, we're going to want to try to get x alone by first subtracting our 6 and then we're going to square root to cancel off that power. So we have x squared equals 12, and we square root that. And by that, I mean both sides always. Now, root 12, we need to break that down to see if there are any pairs. If there are some pairs, they're going to have to leave the root, and then if there's not, then we would be done. But let's find out by breaking it down. So we're going to go 4 times 3, 2 times 2. So the pair of 2's is going to leave the root. The 3 is not going to leave the root. So our final answer, I'll write it right here, would be 3 inside, 2 outside, so 2 root 3. Ta-da! It's beautiful. It's a beautiful thing. Again, Pythagorean theorem, very, very useful in so many situations. So let me give you some practice ones. So I always like to give you some practice ones and then encourage you to pause the video, and then I will write everything out, all the steps, and then you get to see if you did them correctly. So that's what's coming up next. Are you ready? Okay, these are the questions. Pause the video. Pause. Pause. And when we come back together, I will have everything written out, and hopefully all our answers will match. So, ready? 3, 2, 1. How did you do? So I wrote out all of the steps. Hopefully you can keep track of where I went from each step to step. I kind of had to run out of room and then go over here. So the answer to this one is 2 times the square root of 69, because the 3 and the 23 couldn't leave, so they had to stay inside and just multiply together. On this one, you had 2 numbers that could leave, so those multiply outside, and then the 2 had to stay underneath. On this one, we only had 2 pairs, so they leave the root and multiply, but that just means that there's no more root, because the square root of 196 is just 14. So please let me know how you did in the comments. Please let me know if you have any other questions. The Pythagorean theorem really can be applied to a lot more types of problems. Now notice we didn't really talk about any of the angles at all. Like, other than the 90 degrees, we didn't say this is 30, this is, whatever. So when you start throwing angles into the mix, that's where you get into the famed and exciting and wonderful SOHCAHTOA. Now that is a big topic, and I would love to cover it if you guys would love to hear it. So I hope that wherever you are, you're having a beautiful, beautiful day, and I can't wait to see you next time. Thanks so much for joining me. Bye, guys.